Let me start recording. Okay. Any question from this, the problem for this week? No question? Okay. Here we have the first problem. We have each of the two drums and connected hubs of 8-inch radius, weight 200 pounds, and has a radius of gyration about its center of 15-inch. Calculate the angular acceleration of each drum and friction in each bearing is negligible. Here we have two, in fact, two pulleys which are connected to a cable. This cable in case A is attached with a 30-pound mass. In the second case, in case B, instead of that pound, we have a tension of 30 pounds. This problem is to somehow very interesting because you can understand the difference between the tension and the 30-pound weight. Both of them in a static point view, both of them have the same value. But here we have motion. When we have motion, so this mass in case A will have some acceleration. So it will make the problem different from the case B. Okay, so let's solve this and we can compare them in when we deal with this problem. So first we need to plot the free body diagram for the drums and hubs. Here in case A, if you plot the free body diagram, we have a tension T, which this tension T is not necessarily 30 pound. Also, we have the reaction force R, which is the reaction at this joint here, which is a pin connection. And also we have the W1 or the weight of this pulley, which is 200 pounds. So if you plot the free body diagram for the 30-pound weight here, we have W2, which is the weight of this mass, which is 30 pounds. We have the tension T, and also we have the acceleration A. Since there is acceleration here in this free body diagram, so T is not equal to W2 or T is not equal to 30 pounds. But in case B, the tension is equal to 30 pounds and it's easy to obtain the acceleration. But here we need to write the moment equation and force equation for both free body diagrams, and we will have two equations with two unknowns. From the first one, we can write the moment equation about point O, which is the mass center. It must be equal to IO alpha, which IO is the mass moment of inertia about the mass center for this drum. We know the radius of gyration for this drum is 15-inch. So easily we can find the IO, which is the mass moment of inertia, and it's equal to mass times by radius of gyration squared. The radius of gyration is 15. It must be divided by 12 because we should convert it from inch to foot. And M, which is the mass of the hub, which is equal to 200. This is 200 pound. This is the weight. We should convert it into pound mass or slug. For this purpose, we need to divide it by 32.2. Okay, and then in the left hand side we have tension T multiplied by its R, which is this length 8-inch, and it's again it should be converted into foot and we divided it by 12. And also we have W1 and R, both of them located on point O here, so they don't have any moment and only T will create some moment about point O. So from this equation we can extract one relation between T and A. Okay. So the next step here we need to write the equation for this mass, this one. You can write the force equation in y direction, in vertical direction. The summation of the force, which is T and W sub 2, must be equal to the mass times by the acceleration. So W2 minus T is equal to M times by the acceleration. So here we can write that acceleration of this mass is equal to R times by alpha, which alpha is the angular acceleration of this pulley, and R is the distance, the radius of this pulley, which is 8 inch. Again, we should convert it into foot. So this is the equation. Again, we have another equation in terms of T and alpha. So from the kinematics, as I told you, we can write that A is equal to R alpha. Now we will have two equations with two unknowns. One unknown is T and the other unknown is alpha. Now we can solve these two equations for two unknowns T and alpha and obtain T is equal to 14.55 and times by alpha. And when you substitute into the second equation, we can obtain that alpha is 1.9 and T is equal to 28.19. So you can see in the first case, the tension in this cable is less than 30 pounds. And this is due to the motion of this weight in downward direction. But for the second case, case B, it's easier. I mean, you don't need to write the free body diagram and equation for the weight. Easily with one equation, you can obtain the acceleration because we know that the tension in the cable is 30 pounds. So you can write the moment equation again. We have IO, the mass moment of inertia above the mass center. So we will have 30. This time we know that tension is 30 times by its R, which is 8 divided by 12. And only we have one unknown, which is the acceleration of this pulley. And the acceleration is 2.06. You can see when we have the tension 30 pound in the cable instead of the 30 pound weight, we have the acceleration which is more than the case one. Here in case one, it was 1.9, but here is 2.06. So the acceleration is changed and also the tension in the cable is more than the case A. Is it clear? Any question? No, I several times mentioned this. Um, in the exam, I will give you any question that I will give you in the exam. It will be in SI system. In SI system, all of the meters, lengths and dimensions are in meter. But here in this example, the dimensions are in pound inch or in US unit system. In the exam, we don't have any inch or pound. All of the problems are in SI unit system and are in meter and kilogram and Newton, okay? So don't worry about these conversions, the G or 12 in inch to foot, okay? Yes, exactly. Of course, in the exam, maybe, for example, I give you the radius is, for example, 8 centimeter. In your calculation, you needed to convert it from centimeter to meter, but we don't have inch or foot, okay? We have meter, centimeter, or millimeter, or for example, Newton, kilonewton. Maybe you should convert kilonewton to Newton, but there is no pound or inch in the exam, okay? Any other question from this problem? Okay. The second problem, this is a homogeneous cylinder, which is released from rest on the ramp. If theta is equal to 40 degrees, mu s is 0.3 and mu k is 0.2. Determine the acceleration of the mass center G and the friction force exerted by the ramp on the cylinder. I told you in this type of problems, we need to assume, first we assume that we have the motion without slipping, because we have two options. The motion can be with slipping or without slip. I'm sorry, I was disconnected again. Can you hear me now?
Yes.
Okay, so let's continue. So in this case, again, the dimensions are in US unit system. Again, if I give you some question like this in the exam, I will give you in SI unit system. I mean, instead of, for example, 8 pound, you will have some value in newtons. So just the procedure is the same, just the values and conversions will be changed. Okay. So we have again two options. The first option is rotation with sleeping. The second option is without sleeping. We start with without sleeping, because when you assume that your motion is without sleeping, you can, at the end of your calculations, you can check your calculations. When we have rotation without sleeping, we know that the acceleration of the mass center is equal to r times by alpha, which alpha is the angular acceleration. So you can write the force equation in x direction. Again, x, you can see this is the x-axis, is parallel to the inclined surface with angle 40. Yeah, yes, here this is the angle of the incline. If you write the force equation in x direction, it's equal to m times by ag, the acceleration of the mass center. And instead of ag, we can substitute r alpha. Also, you can write the force equation in y direction, which y direction is perpendicular to the inclined surface. But in this direction, there is no motion, so the acceleration is 0. So in the right-hand side of the equation, we have 0. So we can conclude that the normal reaction at this surface, this n, is equal to W cosine theta, which theta is 40 degrees. So for this force in x direction, we can write W sine theta, the x component of W, minus F, it's equal to mr alpha. So here we have one equation, this one. The second equation can be obtained from the moment equation about the mass center. If you write the moment equation about this point mass center, only the force F, which is the friction, will create moment about point G, because W is exactly on this point, so it doesn't have any moment, and the force N will pass through this point, so there is no moment due to the normal reaction. So the moment equation results in the equation 2. You can see F times by R, which is the arm of force F. You can see when you calculate the moment about mass center, the arm for force F is equal to this length, which is the radius. It's equal to the mass moment of inertia about the mass center for a disk is equal to half mr squared times by alpha, which alpha is the angular acceleration. So we have two equations with two unknowns. One unknown is F and the other one is alpha. If you solve these two equations, you can obtain F and alpha. By solving these two equations, you can obtain that F is equal to 1.71 and alpha is 27.63. Sorry. Now you can check your initial assumption. We assume that the motion is without slipping. We know that the maximum friction force is equal to mu s times by n, which mu s in this question is 0.3. So 0.3 times by n, and we obtain that n from this equation here. You can obtain that n is equal to W cosine theta. So the maximum F is equal to mu s times by n, or 0.3 times by w cosine theta, which is 1.83. So if you compare, this is the f that we extracted from the initial assumption, and this is the maximum force. You can see that the maximum force is more than the friction force in our calculation. So our assumption is correct. So this wheel with rotate, this cylinder with rotate without a slipping. Okay, so our initial assumption is validated and our calculation is correct. If it was less than, if this maximum F, it was less than the friction force, then we should do the calculation. This time we know that the friction force is equal to the kinetic friction force. The kinetic friction force is equal to this term mu K times by N, which N is the normal reaction. In equation 1, in this equation, the F is known because we know F is equal to mu K times by N, but we cannot write that AG is equal to R alpha. Here, we cannot use this term. We will have MAG. And finally, in equation 1 and 2, we have two unknowns, but this time the unknowns are AG and alpha. Then you can solve these two equations for two unknown AG and alpha. Okay. Any question?
No, sir.
Okay. So if you don't have any question, we can wrap up this session.